Okay guys, so I'm just going to start going through this review, and we'll start off at the very beginning and I'll just go through one all the way through. So it says y equals the square root of x plus 1 minus 1. So adding 1 on the inside. So remember, inside is the opposite. So we go left 1, and then minus 1 on the outside means I'm going to go down 1. And that is my starting point. So I'm going to go left 1 and down 1 and plot my starting point. Now, there's not a number in the front, and there's not a number on the front of the x on the inside, so there's no vertical stretch or compression, there's no flip, there's no negatives. So I know that the pattern is just the normal pattern, 1, 1, 4, 2, 9, 3. Okay, and I get those from knowing the square roots. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So I'm going to go to the right 1 and up 1 from my starting point, to the right 4 and up 2 from my starting point, 1, 2, 3, 4, up 2. And then I'm going to go to the right 9 from my starting point. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. And that is my first graph, okay? Now we do need to state domain and range. So when I think about domain, domain is left and right. The farthest to the left it goes is -1, and then it goes all the way to infinity. So -1 to infinity. Now range is up and down. So when I think about the lowest it goes is -1, and the highest it goes is infinity. So, -1 to infinity. Okay? Okay, now on number 2. It actually does not move left and right. There's nothing on the inside with the x, but the +5 is on the outside, so I do need to go up 5 and place my starting point. Again, there's no vertical stretch or compression, there's no flip over the x over the y, so I'm just going to follow my pattern. To the right 1, up 1, to the right 1, 2, 3, 4, up 2, and then to the right 9, up 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And then I connect, okay, and then domain and range. Domain is left and right, so the farthest left it goes is 0 on the x-axis, and then it goes to infinity. Range is low and high. The lowest it goes on the y-axis is 5, and then it goes up to infinity. Okay? So then let's talk about number 3. On number 3, we have this negative in the front. So what you have to remember is that a negative in the front of your function actually makes it turn negative. So instead of all the numbers being positive, they're negative. So I know that instead of my function looking like this, it's going to look like that. Okay? Now the 2 in the front is a vertical stretch by a factor of 2. Now if it's a vertical stretch, then you're changing the vertical lengths of your pattern, meaning 1, 1, 4, 2, 9, 3. You're going to be changing the heights, okay, by a factor of 2, which means you multiply by 2. Okay, so this is actually going up 2, up 4, and up 6. Okay, so there's no plus and there's no, plus or minus on the inside. There's no plus or minus on the outside, so I don't go anywhere to make my starting point. But then I do need to go to the right one, but I do need to go down, and then I need to go down 2. And then I'm going to go to the right 4, but instead of going up 4, so think of it like this. 1, 2, 4, 4, 9, 6. So right 1 down 2, right 4 down 4, right 9 down 6. And then connect. Okay? So then domain and range. Domain is left and right, so the farthest to the left it goes is 0, the farthest to the right it goes is infinity. Range is low to high. Okay, so the farthest up it goes is 0, and the lowest it goes is -infinity. So my range is -infinity and 0. Okay? Alright, number 4. Number 4, I'm going to go to the left 3, and then I'm going to go down 3. I'm going to go left 3 and down 3. And then this number on the outside is a vertical change. It's a vertical stretch by a factor of 3. So when I go to the right 1, I'm not going to go up 1, I'm going to go up 3. When I go to the right 4, I'm not going to go up 2, I'm going to go up 6. And when I go to the right 9, I'm not going to go up 3, I'm going to go up 9. Okay? So I'm going to go right 1, up 1, 2, 3. 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. And then I'm going to go to the right 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I vertically stretched it, because normally it would be over 1 up 1, over 4 up 2, and over 9 up 3. That would be the normal one, but we vertically stretched it by a factor of 3, which means we multiplied all the heights by 3. Okay? So domain is left to right. The farthest to the left it goes is -3. The farthest to the right it goes is infinity. Range is up and down. The lowest it goes is -3. The highest it goes is infinity. So there you go. Okay. Now let's try number 5. Okay. So in number 5, you have a couple things to think about. This number in the front is a vertical compression, which means you're changing the heights of your pattern by a factor of 1/2. Now the number on the inside, you've actually got 2 numbers on the inside, and you've got to remember, anytime you have something in front of, just kidding, anytime you have a number in front of this, in front of the x, you always, a negative ordered number, you've got to factor that number out. And when you factor, it's like dividing. So bx divided by b is just x. But then you got to divide that number by b. And that's what you should end up with. Okay? So let's do that exact same thing. 1/2 times the square root of 1/2, and I'm going to factor it out. When I factor a 1/2 out of 1/2 x, out of 1/2, so when I factor a 1/2, it's like dividing it. 1/2 divided by 1/2 is 1, so it's just 1x. But when I factor a 1/2 out of 3, well, you can think of it as 2 different ways. How many halves are in 3? 1, 2, 3, 4, 5, 6. So there are 6 halves in 3. Or, when you divide by a fraction, if you just flip and multiply by its reciprocal, and those cancel out, and 3 times 2 over 1 is just 6. Okay? So either way, I get 6 right here. So that actually means I'm going to go to the left 6. I don't go up or down because there's no plus or minus out here. Now let's talk about our pattern. Remember, it's 1, 1, 4, 2, 9, 3. But on the outside is exactly what it seems. On the outside, if I have plus 2 on the outside, then I'm going up 2. But if I have multiply, then I'm multiplying the heights by 1/2. So 1 times a half is a half, or 0.5. 2 times a half of 2 is just 1, and then a half of 3 is 1.5. So my heights are going to be 0.5, 1, and 1.5. But the horizontal change is a horizontal, see, that was a vertical compression. This, opposite on the inside, is a horizontal stretch by a factor of not 1/2, because remember, opposite on the inside, by a factor of 2. So you flip the fraction, whatever that is, you flip it, and that means that I'm going to multiply all my widths by 2. Okay, so 2, 8, and 18. Okay, so I'm going to go over 2 and up 0.5, over 8 and up 1. So let's go ahead and start from there. So I went to the left 6 because of that. And then I'm going to go to the right 2, which is at -4, and then up 0.5, so right there. I'm going to go over 8, so 2, 4, 6, 8, and then up 1. And then I'm going to go over 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, and then up 1.5. Okay? Just so you have a clear idea of what the graph would have looked like if I hadn't done all those transformations. the normal one starts at, like, if I had just started here, but then I traveled the normal slope, it would be over 1 up 1. And then over 4. So 1, 2, 3, 4, up 2. And then over 9. So that's 4, 5, 6, 7, 8, 9, and up 3. So hopefully you can kind of see how we vertically compressed, because it's not as tall as it would have been. And then we horizontally stretched because that, instead of being right here, it's right here. Instead of being right there, it's right there. And instead of being right there, it's right there. Okay? So that's not my answer. This is. But I'm saying you can kind of see the vertical compression. So it got skinnier, but then the horizontal stretch because it got wider. Domain and range. Domain is left to right. Farthest left it goes to -6. The farthest to right goes to infinity. Range is low to high. The lowest it goes is 0. The highest it goes is infinity. Okay. Now let's do number 6. So number 6 has this negative on the inside. Okay? So what I have to do is I have to remember anytime I have a number in the front, even if it's just a -1, I have to factor it out. So when I factor a -1 out of a -x, that's like dividing, that becomes just a positive x. When I divide a -1 out of -5, I'm left with a +5. And then +3. Okay? So order of operations tells me that I need to think about this negative first. So this negative on the inside actually means that I'm going to flip over the y-axis. Okay? So instead of looking like this, I'm going to look like that. And then the transformations I can pretty much do in whatever order at that point. I'm going to go left 5 and up 3. So here's left 5 and here's up 3. Okay? Now, there's no number in the front, like a 2 or 1/2 or a third, so there's no vertical stretch or compression. And other than a 1, there's no number, a -1, there's no number in the front. So the pattern is as usual. I just need to go this direction. Okay? So I'm going to go over 1, up 1, but I'm going to go in the opposite direction. And then over 1, 2, 3, 4, up 2, 5, 6, 7, 8, 9, 1, 2, 3. Okay? So when that negative is on there, it flips it, and then pattern now does this. 1, 1, 4, 2, 9, 3, and it goes that way. Okay, domain and range. Well, domain is left and right, so the farthest left it goes, see that arrow? It means it goes to -infinity, and then it stops at -5. Okay, range is low to high. The lowest it goes is it stops at 3, and it goes up to infinity, so 3 to infinity. Okay. Let's talk about inverses. So I have y equals x plus 4 quantity squared minus 1. Okay, so that parabola. You're starting with a full parabola, and the idea is to find the inverse in its domain and range. Okay, so first I'm just going to kind of sketch that parabola. It's a parabola shifted to the left 4 and down 1. So left 4, down 1. Yeah? There's my parabola, and then I gotta figure out its domain and range. Okay. So domain is left to right, so it goes all the way left and it goes all the way to the right, so all real numbers, which means the range of my inverse is all real numbers. And then its range, the range is low to high. So it looks like the lowest it goes is -1 and the highest it goes is infinity. It goes from -1 to infinity. So -1 to infinity. Okay. Now, I'm going to find the inverse. And I want to think about a couple things as I do this. Does it make sense that if I start with a full parabola, that I should end up with a full sideways parabola? Yeah. So if I start out with something over here, then it makes sense that my inverse should be something like that across. So it's a reflection of that across there. So I should have the positive and the negative radical. Okay? So x equals y plus 4 quantity squared minus 1. Next step, I'm going to add the 1. So I've got x plus 1 equals y plus 4 quantity squared. I need to get rid of the square, so I take the square root. And when you square root, you've got to remember that there are two answers, plus and minus. So I'm at plus and minus square root of x plus 1 equals y plus 4. I need to solve for y, so I'm going to subtract 4. I can't combine that with anything inside a square root. So x plus 1 minus 4 equals y inverse, or y inverse equals that. Okay? So I've got my plus and my minus radicals. That give me the reflection of a full problem. And that is my answer. With these being my domains and ranges. Okay. Now on number 8, I've got y equals a negative x plus 3 squared plus 4. So again, I want to start out with just thinking about the problem. That problem is shifted to the left 3 and up 4. And there's my vertex, but the fact that it has a negative in the front means it doesn't open up like the other problems. It opens down. Okay? So let's find the domain and range of my function and its inverse. Domain is left and right, and since this keeps going left and keeps going to the right, so I'll run numbers for both. And then the range is up and down, so the lowest it goes keeps on going down to negative infinity, and then it goes up to, and it stops at 4. So negative infinity to 4. Okay, now I need to find the inverse. So I'm going to switch x and y. And the next thing I'm going to do is subtract the 4. I have a lot of people right now that tell me 4 minus x, and that is very, very, very wrong. Don't do that. Okay? There's a number actually in front of this parenthesis right here, and it's a negative 1. I need to get rid of that, so I divide by negative 1, or I just change the signs. Negative x plus 4 equals plus 3 quantity squared. I want to get rid of these squares, so I square root both sides. And when I square root, there are two answers. Okay, I need to get rid of the 3. So the last step, I'm going to subtract 3. I subtract 3 here, subtract 3 there. Plus and minus the square root of negative x plus 4 minus 3 equals y inverse. Or y inverse equals that. Okay. Now I don't have to worry about any domain issues or anything on these two because I started with 4 parabolas. And so it was just a matter of making sure that I put the plus and the minus on the inverse so that I knew that I have the right function. Okay? So, when I have something like 9, 9's another normal one. Y equals 2 times x minus 5 quantity squared. Okay, I'm starting with a parabola that is shifted to the right 5. So, alright, that didn't go up or down any domain and range for y and then y inverse. Okay, domain is left and right. So the farthest to the left it goes, and the farthest to the right it goes is all negative and positive infinity, so all real numbers. And then range is up and down. The lowest it goes on the y-axis is 0, and then the highest it goes is infinity. So 0 to infinity. Okay. I want to find the inverse, so I'm going to switch x and y. And then I want to solve for y. I have all this stuff y minus 5, and then I have it squared, and then multiplied by 2, so I'm going to get rid of the 2 in the front first, because it's outside the square root, or the square. So x divided by 2 equals y minus 5 quantity squared. Now I want to get rid of the square. The opposite of the square is the square root. So square root that, plus and minus. So I've got plus and minus the square root of x divided by 2 equals y minus 5. I'm going to solve for y. I add 5. So plus and minus the square root of x divided by 2 plus 5 equals y inverse. Okay. And like I said, as long as you start with a parabola, there's no big issue. If you start with a parabola with a restriction, then you got to think about some other things. But just a regular parabola, plus and minus, and you're good. Okay. Let's do 10. Number 10 is one where I start with a radical, and that means I have a domain issue. So y equals the square root of x plus 4 minus 2, which means I'm starting with a radical that shifted to the left 4 and down 2. And then I know it just opens to the right like a normal radical. Okay? Now, I need to find its domain and range. So y domain range. The original function is only this positive radical, right? So its domain is left and right. The farthest left it goes is negative 4, and then it goes all the way to infinity. So that's the range as well. Then what about the range of the original? Well, the range is low to high. So the lowest it goes is negative 2, and it goes up to infinity. Low to high. And so then the domain of the original is that. Okay. So, now I need to find the inverse. So the first thing I'm going to do is switch x and y. X equals the square root of y plus 4 minus 2. I need to add the 2 to both sides. So I get x plus 2 equals the square root of y plus 4. I need to get rid of the square root by squaring both sides. So x plus 2 quantity squared equals y plus 4. Okay? And then I need to subtract the 4. So I subtract the 4, subtract the 4. And then x plus 2 quantity squared minus 4. Now, if you stopped here and said y inverse, you would not be completely correct. Because if you graph that parabola right now, what's left 2 down 4? So it would look something like this. But it doesn't make sense for the reflection of only half of a sideways parabola to be a full upright parabola. So it makes more sense if this part was not there. Meaning the reflection of this would make sense to be only this half of the parabola. Okay, so like I said, when we were doing this in class, if you start with a radical, you're going to have a domain restriction. And if you find your domain and range first, you already know your domain restriction. It can only be from negative 2 to positive infinity. So what I do when I write my answer is write y inverse equals that parabola. But the domain restriction is that it only exists from negative 2 to infinity, right here. It only exists on this side, not the other side. It's not even there. That's why we marked it out. So we say x has got to be, because it's negative 2 to positive infinity, greater than or equal to negative 2. And then that's my answer. That's my inverse. Okay? You start with a radical, then you only have half a parabola. If you start with a positive radical, you should end up with the right side of the parabola. But if you start with a negative radical, you should end up with the left side of the parabola. So y equals negative 2 square roots of x plus 5. Let's talk about graphically what happens, what this graph looks like. Okay, so just the square root of x, I multiply it by 2, that just makes it a vertical stretch. A negative, though, flips it, and then plus 5 moves it up 5. Okay, so let's do domain and range. Okay, so domain is left and right, so the farthest to the left it goes is 0, and it goes all the way to infinity. Range is low to high, so the lowest it goes is negative infinity because of this arrow, but the highest it goes is 5. So negative infinity to 5. Okay, that is our domain restriction, and we'll have to use that in just a minute. If you start with a radical, you're going to have a domain restriction. So I switch x and y. X equals a negative 2 square roots of y plus 5. I subtract the 5. I want to get rid of the negative 2, so I'm going to divide by negative 2. I don't like dividing by a negative, so I'm going to float the negative to the top. Negative x plus 5 divided by 2 equals the square root of y. Also could be written as negative 1/2 x plus 5x if you want to. And then I want to get rid of the square root, so I square both sides. So negative x plus 5 over 2 quantity squared equals y inverse. But it's only on a restricted domain. So I've got to remember this, comma, x has got to be, since it's the left side, negative infinity to positive 5, x is going to be less than or equal to 5. If it's from a number to infinity, you're talking about the right side, but on the number line, we're talking about this side, so x is going to be less than or equal to 5. Okay? On 12. Okay, here I'm starting with a parabola, but I'm actually starting with a restricted parabola. It's only defined for x greater than or equal to 0. So this parabola has no horizontal or vertical stretching, there's no flipping, but it does go up 6. But the fact of the matter is that we're not dealing with part of that problem. We're not dealing with this half, because it only says for x is greater than or equal to 0. So in actuality, the graph that we're looking at is only that part. Okay? So let's find the domain range. Okay, so the domain is left to right. First to the left it goes to 0, and then it goes all the way to infinity. Range is up and down. The lowest it goes is 6, and the highest it goes is infinity. That being said, though, if I only start with half a parabola, then it makes sense that I should only end up with half a sideways parabola. So when I find the inverse, the positive one is going to be like this, and the negative one is going to be like that. But just like we don't include the left side, we're not going to include the negative side. It's only going to be the positive. Okay? So I'm going to switch x and y. And then I'm going to minus the 6. And then I'm going to take the square root. I almost always say plus and minus. And I do encourage you to do that. But then recognize the fact that this was the right-hand side, the positive side. So we're only going to add the positive answer. And if you actually sketch that radical, it goes to the right 6 and goes up. This domain is 6 to infinity. Its range is 0 to infinity. So it makes sense. But if it had been up and down, then it would have been range all raw numbers, which would not have worked. Okay. On number 13, I need to find the inverse So first I'm going to sketch to the right 2 down 5. And it's only for x greater than or equal to 2. So though my problem usually does this and then does that, we're only going to draw that side. Okay? So if it says x is greater than or equal to 2, then I only draw the right-hand side of the parabola from 2 on. So domain and range. Domain is from negative, 2 to infinity. So go to 2 and then go all the way to infinity. And then range is up and down. So the lowest it goes is negative 5 and the highest it goes is infinity. Okay? So we need to find the inverse. So x equals 2/3 y minus 2 quantity squared minus 5. I need to add the 5 to both sides. So x plus 5 equals 2/3 y minus 2 quantity squared. I need to get rid of the 2/3. You can break it up and multiply and separate them, or you can do them at the same time. I'm going to go ahead and break them up just so you can see, but well, I guess I'll do it 2 different ways. Okay, so one method is to separate them and say, like, you're dividing by 3, so the opposite of dividing by 3 would multiply by 3. And so then you got 3x plus 15 equals 2 times y minus 2 quantity squared, and the opposite of multiplying by 2 would be to divide by 2. So you get 3x plus 15 divided by 2 equals y minus 2 quantity squared. The other way is to get rid of them at the same time. The opposite of multiplying by 2/3 is to multiply by 3/2. Same thing, you're multiplying by 3, which cancels out division by 3, and you're dividing by 2, which is what we did, to cancel out the multiplication by 2. Now, I could just shoot my 3/2. That would be 3/2 x plus 15/2, but I can just also leave it like that. I want to get rid of the square, so I square root both sides. When I square root, there are 2 answers, plus and minus, but I only was given the right-hand side of the parabola, so I should only end up with a positive radical. Okay, I need to get rid of the 2, so I'm going to add 2. And that is y inverse. Okay. So now, I mean, that's a lot of inverse, and it's a lot of things to think about. I'm not going to make all of them the hardest, but I'm also not going to make them all super easy. So anyway, just try and remember all the different things that you need to think about for each type, and just do that by practicing. Okay, so now I'm going to go to solving. Okay. I want to solve for x, and right now it is underneath that square root, so I need to move everything away from that. So I've got the square root of 2x equals 4. I need to get rid of the square root, so I'm going to square both sides. If I square this side and that side, I'm left with 2x equals 16. I want to solve for x, so I divide by 2, and I'm left with 8. It's a square root, so I'm going to check. Is the square root of 2 times 8 plus 6 equal to 10? That's 16. Square root of 16 is 4. 4 plus 6 is 10. So that is my answer. Okay. On 15, I need to get rid of the square root. So the only way to get rid of the square root is to square, but I have to square the whole side of the equation. So I'm left with n minus 1 squared, which equals n minus 1 times n minus 1, which equals n squared minus 1n minus 1n plus 1. Okay? That's a negative 2n, so I'm left with n squared minus 2n plus 1 equals a negative 4n. Okay, so the idea is to get rid of the square roots. By squaring both sides, when I square the left-hand side, I have to FOIL that out or distribute it. And now I have this whole expression. What I need to do is get everything on the side of the square. So I'm going to add 4n and have n squared plus 2n plus 1 equals 0. And what I want to do is I want to try and factor. So find factors of 1 that add up to 2. I think of 1 and 1. So you could say n plus 1 times n plus 1, or n plus 1 squared, which means n equals negative 1. But then you have to check it. It's a square root. So whenever I see a negative 1 in my original problem, I'm going to plug in negative 1. So I've got negative 1 minus 1 equals, with a question mark, the square root of negative 4 times negative 1. Well, negative 1 minus 1 is negative 2, and that is the square root of negative 4 times negative 1, which is positive 4, which is 2. And they do not equal each other. So since that's not a solution, and that was the only one I had, there is no solution. Okay? Alright, now moving on to this one. I need to solve for n, so I'm going to subtract 2 and get 3 times the square root of n minus 5 equals 9. I'm going to divide by 3. And I've got the square root of n minus 5 equals 3. I'm going to square both sides to get rid of the square root. And I'm left with n minus 5 equals 9. And then I'm going to add 5, and n equals 14. There's a square root, so I'm going to check it. 3 times the square root of 14 minus 5 plus 2, does it equal 11? 14 minus 5 is 9, square root of 9 is 3. 3 times 3 is 9, plus 2 is 11. So that in fact does work, that is my answer. Okay. Alright, now 17 I changed, so let's work this problem. To get rid of the square root, I'm going to square both sides. So I'm left with 49 minus 4x. We already squared n minus 1 right here, so it's x minus 1 is the same thing. X squared minus 2x plus 1. Okay, I need to get everything on the same side as the quadratic. So I'm going to subtract 49, and I'm going to add 4x. So I'm left with x squared plus 2x minus 48 equals 0. So what I'm trying to do is find the factors of 48, negative 48, that add up to 2. So I'm thinking 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. 6 and 8 have a difference of 2, so I need a positive 2, which means I need 6 to be the negative 1. So x minus 6 and x plus 8, then those equal 0 when x equals 6 and negative 8. But I need to check those answers. So the square root of 49 minus 4 times 6 equals 6 minus 1 question. 4 times 6 is 24, 49 minus 24 is 25, and the square root of 25 is 5, which does equal 6 minus 1. So that is an answer. But then let's check negative 8. The square root of 49 minus 4 times a negative 8 equals a negative 8 minus 1. That's a negative 9. That is 32. 32 plus 49 is 81, and the square root of 81 is 9, not negative 9. So negative 8 is not a solution. That's an extraneous one. Okay? Okay, so then we do this one. I need to get rid of the square root, so I square both sides. V squared equals 20 minus V. I need to get everything on the same side as the radical. So I'm going to subtract 20 and add V. So V squared plus V minus 20 equals 0. I need to factor. Are there factors of negative 20 to add up to the 1? is the number on the inside. And factors of 20 that add up to 1 are negative 4 and positive 5. So v minus 4, v plus 5. The answers are 4 and negative 5. But I'll now check them. Does 4 equal the square root of 20 minus 4? And that is 16, and the square root of 16 is 4. So yes. Does negative 5 equal the square root of 20 minus a negative 5? That is 25, and the square root of 25 is 5, which is not equal to negative 5, so that is not a solution. Okay. On 19. 19, I've got 2 square roots, and what you don't want to do is fall into the trap of squaring things right away. What you can do, however, is if you add this to this side and that side, then you're left with the square root of 7k equals the square root of 9 minus 2k. And the opposite of the square root is the square. So I'm going to square both sides, and I'm left with 7k equals 9 minus 2k. I want to solve for k, so I want to combine like terms. I'm going to add 2k to this side and to that side. 9k equals 9. And then I want to divide by 9 to get k by itself. And I'm left with k equals 1. And I'm going to check it. Square root of 7 times 1 minus the square root of 9 minus 2 times 1 equals 0. That is 7. That is 7. Square root of 7 minus square root of 7 equals 0. And it does. Okay. K equals 1. Okay. The opposite of the cubed root is the cube. So when I take the cubed root of 2 different sides, if I just cube both sides, then they cancel each other out. And I'm left with 2x plus 18 equals negative 6 minus x. So I'm going to try and get everything on the same side. Well, I'm going to try to combine like terms. I'm going to add the x to this side. And then I'm going to subtract 18 to this side. And then I'm going to divide by 3. And I get x equals a negative 8. Now, I don't really need to check my answer because it was a cubed root, but I'll go ahead and, for the sake of it. That is a negative 16, 2 times negative 8, and negative 16 plus 18 is 2, so the cubed root of 2 equals, hopefully the cubed root of 2. Minusing a negative 8 is plusing, so that is the cubed root of 2, that is a true statement. Okay. Now on 21, you start out with the 5th root of x, and then you got minus 3 plus 2. So what I want to do, or equals 2, so what I want to do is add 3 to both sides to get the x by, or the 5th root of x by itself. And then I want to take the 5th power. So to get rid of the 5th root, you raise it to the 5th power. Let's cancel each other out. X equals 5 to the 5th. I use my power chart, and it's 3,125. Okay? And there you go. Now on 22, I'm starting out with x plus 4 to the 1/4 plus 5 equals 3. So I'm going to subtract 5 and say x plus 4 to the 1/4 equals negative 2. So in order, what you got to do is think of this as a root and a power. Now, the 4 in the denominator is the root. So this is the 4th root of x plus 4 to the first power, but raising it to the power of 1 doesn't do anything, so I don't have to worry about it. So this is an equivalent statement. These two are the same equation. So how do I get rid of a 4th root? I raise both sides to the 4th power. And those cancel out. X plus 4 equals a negative 2 to the 4th. It's like saying negative 2 times negative 2 times negative 2 times a negative 2. A negative times a negative is a positive, times another negative is a negative, times another negative is a positive. So it's all positive. 3 times 2 is 4 times 2 is 8 times 2 is 16. Positive 16. So I solve by subtracting 4, and x equals 12. But it was an even root, so I need to check it. a fourth root. So 12 plus 4 to the 1/4 plus 5, does it equal 3? So, what's the total of 3? Okay. 12 plus 4 is 16, and that is the fourth root. The fourth root of 16, if you use your power chart, since 2 to the 4th is 16, the fourth root of 16 is 2. 2 plus 5 equals 7, which is not equal 3. That means that answer is extraneous. Okay, on 23, I need to solve. So I've got 3x to the 2/3. I'm going to add 5. I think I told you to make it 5 already. So I think I said make that plus 5 so that you would subtract 5 from both sides. Okay, so that should have been a plus 5. So we're going to actually subtract 5 from both sides, leaving me with 3x to the 2/3 equals 192. I need to get rid of the 3 that I'm multiplying in the front. This is not this. If I meant that, I would have written it the first thing, but I didn't. So the only thing being raised to the 2/3 is the x. So divide by 3, and that is 64. Now you need to rewrite what this is. This is the same thing as the 3's on bottom, so it's the cubed root of x squared equals 64. Okay? Or the cubed root of x squared equals 64. It really doesn't matter. I'll work it both ways. So in the first way, to get rid of the cubed root, you cube both sides. Now you get, oh my gosh, I think it's 262, 144, but I'm not positive. Yeah. Okay. So then we want to get rid of the square, so you take the square root, and when you take the square root, there are 2 answers. So I take the square root, x equals plus and minus the square root of 512. So I just take the square root of that and get 512. The other option is over here to get rid of the square first. I take the square root. And when I take the square root, there are 2 answers. So I got the cubed root of x equals plus and minus 8. How do I get rid of a cubed root? I cube both sides. Okay? Well, a positive 8 cubed is 512. And a negative 8 cubed is a negative 512. So plus and minus 512. And you get the same thing. Okay, let's go on to 24. Completing the square. When completing the square, you definitely want to move the constant to the other side. A squared minus 8a equals 20. And then you want to divide. So this middle term, negative 8 divided by 2, is negative 4. So that goes inside here. But then you have to add whatever that number is squared to both sides. So that number squared. And that is negative 4 squared is positive 16. So I'm going to add 16 to both sides, and I'm left with 36. And then I want to solve. So I'm going to get rid of the square by square rooting. Plus and minus. A minus 4 equals plus and minus 6. And then I'm going to get rid of the 4 by adding it. 4 plus and minus 6, or plus and minus 6 plus 4. Doesn't really matter. 4 plus 6 is 10. 4 minus 6 is negative 2. 6 plus 4 is 10. Negative 6 plus 4 is negative 2. Either way, you get the same answers. I don't have to check these because they're quadratics. They're not radicals. So those are the 2 answers. Don't put parentheses because that looks like a coordinate point. Or an interval, I guess. Okay. I want to move the constant over, so add 24. Cut the middle number in half. 2 cut in half is 1. So v plus 1, quantity squared, equals, I square that number, So 1 squared. 1 squared is 1, so I add 1 here, add 1 there, and I get 25. So now I want to get rid of the square, so I square root both sides. Plus and minus. V plus 1 equals plus and minus 5. I'm going to subtract the 1 to get V by itself. So V equals a negative 1 plus and minus 5. Negative 1 plus 5 is 4. Negative 1 minus 5 is negative 6. And there we go. Okay. Okay. I am running out of time, so I'm not going to work through those, but I have the answers posted on iLearn. I'm pretty sure to those. So let me work through a few of these right here. Let's keep in mind that when you do inequalities, if I'm asking you when is this parabola greater than 0, we are talking about when is it above the x-axis. So that is here and here. That is when it's greater than 0. If I ask you when is it less than 0, then I'm asking you when is it below the x-axis, which is between those two numbers. So your answers are only ever going to be from negative, well, I guess I should do that in orange or yellow. If it's the first one, if it's outside, then it's negative infinity to that first number, let's say A, and then pick back up at B and go to infinity, because you're talking about the outsides. But if it's less than, if it's the green, then it's between the two numbers. So your answers are only ever going to look like this, with the only difference being brackets versus parentheses, okay? So, on 28, when it says x squared minus 2 is less than 9, first thing you want to do is get x squared by itself. So you're going to add 2, and you're left with x squared is less than 11. Okay? The x squared is less than 11, so I want to get rid of the square root or the square by square rooting. When you square root, there's actually 2 answers. So I got to put the positive square root of 11 over here, and the negative square root of 11 over here. Okay? Now, you just ask yourself, does this make sense? Is the negative square root of 11 less than the positive square root of 11? And if it does make sense, then it's between the two numbers. Now, I used, that's not part of the problem. I use parentheses because it doesn't equal to. It's not including. It's just the less than or greater than, okay? Alright, so on this one I need to divide by 4. So I've got x squared is greater than or equal to 8. Again, I want to take the square root. If I take the square root of both sides, there are 2 answers. X is greater than or equal to the positive square root of 8. Repeat the symbol exactly and do the negative square root of 8 there. 8 is 4 times 2, so I'll go ahead and write 2 root 2 and 2 root 2 with a negative. Okay, so then I ask myself, does this make sense? Is this negative number greater than this positive number? And that is false. That's not true. So they work against each other. And if you read that x is greater than or equal to this, so when I see that equal to, I think of the top and the bottom of the brackets. So 2 square roots of 2 greater than, so it goes all the way to infinity. And then negative infinity to negative 2 square roots of 2. Okay? And there's my answer. Now on 30, I want to get rid of the square, so square root before anything else. So x minus 3 is less than or equal to the positive square root of 25. But when I take a square root, there's 2 answers, so now I've got the negative square root of 25, which is negative 5. Okay, I need to get x by itself, so I'm going to add 3 to everything. And I'm left with negative 2 is less than or equal to x, which is less than or equal to 8. So then I ask myself, does this make sense? Is negative 2 less than 8? That is a true statement, which means it's between the two numbers. They are working together. Oh, brackets. Okay. Okay. Let's see, 31. Okay, I want to get x by itself, so the first thing I'm going to do is add 7. So I get 2 times x plus 4 quantity squared is greater than 98. I want to get rid of the 2. This being multiplied out in the front, so when I divide by 2, and I'm left with x plus 4 quantity squared is greater than 49. I want to get rid of the square, so I'm going to square root. When I do, I'm going to have the positive 7 here and the negative 7 there. And then I want to get rid of the 4, so I'm going to subtract 4. And I'm left with negative 11 is greater than x, which is greater than 3. And is that true? Is negative 11 greater than 3? That's not true, so that means they work against each other. We're going from 3 to positive infinity, and from negative infinity to negative 11. So if it makes sense, then it's between the two numbers. If it doesn't make sense, it's outside the numbers. Okay? Okay. So 32. Alright, 32, it does not look like this, okay? And I don't want to complete the square because the middle number is odd, so I'm going to have to try and factor. Are there factors of negative 28 that add up to 3? 1 and 28, 2 and 14, 4 and 7. 4 and 7 have a difference of 3, so I need the 4 to be a negative, so that I get a positive 3 when I add them. So x minus 4 and x plus 7 has got to be less than or equal to 0. So, what this tells me is that this parabola equals 0 at 4 and negative 7. So if I sketch it, then the parabola should cross at negative 7 and positive 4. And then the question is, where is it less than or equal to 0? To be less than or equal to 0 means to be below the x-axis. So that is between these two numbers. It's got an equal to, so bracket. Okay. 33. I want to get everything on the same side because I've got an x squared and an x, so 2x squared. I'm going to minus 7x over plus 5 is greater than 0. So I'm going to just 0 on that side. Okay, I'm going to try and factor. So I need to multiply 2 times 5 and get 10. So what are the factors of 10 that add up to negative 7, the middle number? And the factors of 10 that add up to negative 7 are negative 2 and negative 5. So x minus 2, x minus 5 is greater than 0, but I got to remember to divide by that number that we multiplied by, the 2. That simplifies down to 1. So I've got x minus 1 and x minus 5 halves. And remember, I don't want to do bottoms up. I don't want to bring that 2 up because I want to know where it crosses the x-axis. So it crosses at positive 1 and at positive 5 halves, which is 2.5. Okay? So I know this is 1 and that's 2.5. Okay? Go back and read the problem. When is it greater than 0? It's greater than 0 when it's above the x-axis, which is on this side of 1 and on this side of 2.5. So it's not between the two numbers, it's outside. So it's negative infinity to 1, and then from 2.5 to infinity. Okay, on 34. First, I'm always going to check and see if it factors. Are there factors of 12 that add up to negative 4? 1 and 12, 2 and 6, 3 and 4. 2 plus 6 gives me 8. Negative 2 plus 6 gives me positive 4. Positive 2, negative 6 gives you negative 4, but when you multiply them, you get negative 12. Which means it doesn't factor. So what I'm going to do is move the 12 over and complete the square. Okay. So I'm going to cut the middle term in half. 4 cut in half, negative 4 cut in half is negative 2. I'm going to square that number. So negative 4 squared, or sorry, negative 2 squared is positive 4. So I'm going to add 4 here, add 4 there, and I'm left with negative 8. Now, when I'm solving these questions, and when you're solving, I want you to think about the real plane and what we're talking about on the x and y axis. So when you take the square root, x minus 2 is less than, you got this, and then you look at this. But to have a square root of a negative number is to say that. And that is not on the real plane. So if I think about this parabola, it's actually above the x-axis, so it's never below, it's never less than 0, or that parabola is never less than -8. So in this case, once you get a negative solution, or an imaginary solution on these inequalities, I'm going to put a real solution. Okay, last one. So does it factor? Are there factors of 16 that add up to 10? 2 and 8. Okay, x plus 2x plus 8 equals 0 when x equals -2 and -8. So, if that's a -8 and that's -2, the only question is, what's the problem asking me? When are we less than 0? We're less than 0 when we're below the x-axis, so between these two numbers. So, -8 and -2, parentheses, because it doesn't say equal to. And there's my review. Okay, I hope that helped, but if you still have trouble, then come see me in the morning. We should be able to figure that out.